So this is part 3 of section 4.1's homework. We'll look at number 21 and probably 24 in this video. In this section it says find the extreme values of the function and where they occur. So really they're pretty much the same as the last part of this assignment, except this time they haven't given us any endpoints. Alright, now I know for some of you this might be a little bit frustrating, but number 21 we kind of already know the answer to. Again, don't forget things that you already know, and being that this is a cubic function, most cubic functions will look something like this. And so if you're being asked what the maximum and minimum values are, I guess technically we already know them on this question, and the answer is there are none. But once again, I'd kind of like to look at the math of this and see how we could arrive at that same answer and only use calculus and not look at the graph. Alright, so this time we don't have endpoints to look at. So when we start talking about looking at endpoints to find the values, we kind of need to change the conversation a little bit. And again, it might be useful for us to look at the limit as we go to infinity. So in other words, since there are no endpoints, what's happening to the right side and then what's happening on the other side. We'll come back and have that conversation once we finish this up. Alright, so let's look at the critical values. And once again, that means we're taking the derivative. And so the derivative is 3x squared plus 2x minus 8. So we're looking for when it's equals 0 or when it is undefined. I hope that it's obvious to you that as a quadratic function, this derivative is never undefined. So what we really only need to focus on is when is it equal to 0. Alright, and if we're lucky, this is going to factor. So let's give it a shot. 1 times 3, 1 times 8, and 2 times 4 are my only options. And so we go to factor. We're looking to subtract to get a 2. So 3 times 2 is 6. 1 times 4 is 4. 6 minus 4 is 2. So looks like we have our combination here. So the 1x and 3x, so those will be in the front parts. The 2 and the 4 will be in the back, but we need to make sure it's in the right order. I need to multiply the 3 times the 2. So the 2 needs to go in this spot, and the 4 needs to go here. And I want it to be a positive 2. So the 3 times the 2 is positive, and that would be negative. So I get negative 8, and I get 6 minus 4 is 2. So I factored so I could set each factor equal to 0. And I get an answer of x equals negative 2 or x equals 4/3. Alright, so those are critical values. Those are points of interest. And so what I would like to do at this point is, again, let's do our sign chart. So this time my sign chart, I'm not going to put an endpoints on it because we don't have any. So I've got negative 2 and I've got 4/3. So once again, what I know is that the slope between negative 2 and 4/3 will be the same for all of those values. For all values bigger than 4/3, my slope should be the same, and then the same is true for less than negative 2. So all I need to do is pick a value in these regions. So if I pick a value between negative 2 and 4/3, and again this is a sign chart for the derivative, 0 gets plugged into my derivative and I get negative 8. So I know that it's negative. I plug in a number bigger than 4/3, and you can plug in a number like 2 or 3, or you could plug in anything like a billion. And sometimes the math's a little more easy. We come back here to the derivative. I plug in a billion and square it. I think it's pretty obvious my answer is going to be positive. looking at values less than -2, again, throw in a number like negative a billion. Squared makes positive a billion. And so again, pretty confident that I have plus, negative, plus. So what I know is that my slopes are positive, so that means I'm going up until I get to -2. Then my slope is 0, which is why I was looking at that spot anyway. Then my slopes are negative after that until 4/3, where they hit 0 again. And then afterward my slopes are positive. So what that tells me is that at -2 we have a local maximum, positive to negative, and at 4/3 we have a local minimum, negative to positive. So now what remains is trying to figure out if these values are going to be the absolute max and minimums, or if they're just kind of random local mins and maxes. And so what would answer that question for me? So again, if I don't know the picture, so I haven't investigated this. Right now, this is the information I have in front of me, that I have this local max and local min. So how could it be that this graph would maybe have a absolute maximum here? And the answer is my slopes are positive as I leave 4/3, but maybe they don't grow very fast and actually end up approaching a horizontal asymptote less than 4/3. That would be possible. There's nothing mathematical that we've found that would indicate whether I go up or whether it balances out to an asymptote and is less than 4/3 forever. And then the same thing would be true over here. Is it coming down like this and going below whatever we are at 4/3, or is the slope still negative and curving out like this, still falling, still a negative slope? I'm sorry, still a positive slope, but going towards a horizontal asymptote here. So that is possible. So that is why before I can draw any conclusions, I really need to know what's happening out towards the ends. And that's why, again, I said at the beginning, we really are going to need to take a look at the limit as x goes to infinity on the function. And as we go to infinity, it's pretty obvious, I hope, that the answer is infinity. Plug in infinity, cube it, and we just get bigger and bigger. And as we look at the limit as x goes to negative infinity on the function y, again, you plug in negative infinity and cube it, and you're going to get an extremely negative number. So what that tells me is these local mins and maxes I had over here are just that, just locals. Because whatever we are at 4/3, as a minimum, I'm lower than it as we head to negative infinity. So the graph would not curve out and have a horizontal asymptote. It would, as we already knew, come down and be bigger than our local mins and maxes. So all going back to what we knew within the first few seconds, that there are no local mins and maxes on this. I'm sorry, there are no global maximums or minimums. So let's push on and do the next problem, even though we're at the 8.5 minute mark. And we'll do this one. We'll see if we can do it relatively quickly. So again, no endpoints to check, so that might be something I need to look into. So this is something I'm going to keep in my back pocket and look at. And then let's look for critical values. So let's take the derivative, and I'm going to actually rewrite this as a chain rule. So I'm going to rewrite the problem to be that. So now I take the derivative, negative x squared minus 1 to the -2 times 2x. And so the derivative is going to be negative, this all goes to the bottom, 2x on top, so I get negative 2x over x squared minus 1, the quantity squared. So when is the derivative equal to 0? Again, it's a fraction, so it's going to be 0 only when the numerator is 0, which hopefully is obvious to you. That would only be at x equals 0. And then when is the function going to be undefined? And so that is going to be when the denominator equals 0. And so I look at the denominator, and now I really just want to focus on when is it equal to 0. So take the square root of both sides, you get x squared minus 1 equals 0, x squared equals 1, x equals positive and negative 1. Alright, so those are my critical values, and that's what I need to check. Alright, but it occurs to me, and I saw this about 2 minutes ago, that there's something I did not do that might have been helpful at the beginning, and that is I didn't check my domain of the function. And knowing that it's a quotient, a rational function, I know I can't divide by 0, and so what I really probably should have started with is looking at the domain of the function and quickly realizing that it can't be 1 or negative 1 in the denominator. So this is defined everywhere except for 1 and negative 1. Notice that these two values I found where it's undefined are the same two values where the original function is undefined. So while it is still important for me to identify these points as issues where the derivative is undefined, I ultimately will know that they won't be min or maximums because it's where the function is actually undefined. So there are no points there to begin with. Okay, but let's still put everything on our sign chart and see what happens. So I plug in 0, 1, and negative 1. So then I'm going to look at all other points in the domain and see what the slopes are. So plugging in a value bigger than 1 into my derivative, I get a negative on top. On the bottom I have something squared, which is always going to be positive. So I have a negative divided by a positive, so I know I'm negative out here. Between 0 and 1, a number like, say, a half or 0.1. On top, again, I have a negative number. On the bottom, it's squared again, so it's always going to be positive. I have a negative divided by a positive, still negative. On the other side, again, the bottom's always positive, and no matter what kind of negative number I plug in, it's going to turn it positive on top. So it looks like in both of these regions, my slopes are positive. Alright, so now the question is, what does this graph look like? And at some point, it really would be helpful if we kind of used our previous knowledge and realized that what's happening at negative 1 and positive 1 would be that we have vertical asymptotes. So I know at negative 1, so here's the y-axis, and at positive 1, I have vertical asymptotes. And let's look at the sign charts and see what they tell me. It says my slopes are positive as I'm heading towards my vertical asymptote, and they're positive as I leave my vertical asymptote. So the only way that's going to be possible is if I'm going up, slopes are positive, and as I come from the other side, I'm going up, slopes are positive. So I must be approaching my vertical asymptote in this fashion. And then the same thing's happening over here. I know that as I approach my vertical asymptote at 1, my slopes are negative, and as I approach my vertical asymptotes, or leave my vertical asymptote, my slopes are negative. So that means I'm coming down like this. So what's happening everywhere else? Well, it's time to start thinking about the left and right side. So as I go look at my limit as x goes to infinity, I should see that I've got a relatively small number divided by what will be an increasingly huge number, and small divided by huge is 0. So that tells me I have a horizontal asymptote at 0, and as I go to negative infinity, the same thing's going to happen. I'm going to have 0. So as I leave my vertical asymptote, I go horizontal, and then the same thing is true over here. So now what's happening in the middle? Clearly, if I'm going down, and then going down on this side, at some point I have to have a high point and start curving back down. Notice that would have a slope of 0 at that point, and notice I have located such a point right here with my critical values. I asked it when is the derivative equal to 0, and it told me at x equals 0. So I already know the answer because my asymptotes, I have vertical asymptotes. So that means I'm going up to infinity and down to negative infinity. What's the minimum? What's the maximum? The answer is none. We do have a local maximum here at 0, and if I wanted to find the value of that, I could plug that in and I get actually it's a value of -1. So I know that I come up to -1 at 0 and I go back down. So local maximum. Everything else are vertical or horizontal asymptotes. And it looks like I've gone way long on this question, and we will stop here.